this location is almost optimal for solar power generation. And not only because it's flat, transmission lines were already here, the sun is traveling, and there's no haze, and it's absolutely clear.
Oh yeah, it's clear. The sun travels over the flatness. My man. Oh, finally getting it.
Yeah, if these guys were around when Columbus set sail, they'd be charter members of the Flat Earth Society.
The Columbus joke? Again? You've already said that one. Man, senioritis, or what do they call it now? Puppet speak.
The current members of the Flat Earth Society in Congress, and again, I just want everybody to be clear, because sometimes when you listen to the news and you listen to some of these other politicians, they seem a little bit confused about what I'm saying. You know, the current members of the Flat Earth Society in Congress, you know, they seem a little bit confused about what I'm saying. If some of these folks were around when Columbus set sail, they must have been founding members of the Flat Earth Society. They would not have believed that the world was round. If I say that the world is round and someone else says it's flat, that's worth reporting. But you might also want to report on a bunch of scientific evidence that seems to support the notion that the world is round.
That seems to support the notion that the world is round. Well, let's look into that sentence for just a second here. So this evidence seems, that's kind of like kinda, or appears to point to, or might be right. And notion is a conception or a belief about something, an impulse or desire, especially one of a whimsical kind. Whimsical? Like, I don't know, people living on a spinning ball, perhaps? That's pretty whimsical. Flying 66,000 miles per hour around a sun 93 million miles away. What are some of the synonyms? Idea, belief, conviction, opinion, view, thought, impression, perception, impulse, inclination, whim, desire, wish, or fancy. Well, teaching it in school and from a textbook and making jokes of its opponents doesn't make it true. It makes it a dogma. It makes it a religion.
A bunch of scientific evidence that seems to support the notion that the world is round.
When a man reaches the edge, after he goes as far as any man can possibly go,
because what the system wants to do right across society is get people to focus on dots, individual dots, a religion, family, job, football team, whatever. The idea is to keep humanity constantly bewildered, so we don't know where we are, who we are, what even reality is. But when you connect the dots, and so many of them, as we'll see today, have on the face of it no connection to some of the others. When you connect the dots, the light goes on, and suddenly the picture forms.
Russia's space agency claims to have found sea plankton on the outside of the International Space Station. Wait, what? A report in ITAR TASS quotes Russia's ISS mission chief saying, "We have found traces of sea plankton and microscopic particles on the illuminator surface. This should be studied further." The report claims this finding is part of a long-term study, which proves some life can exist in space. The discovery apparently occurred after Russia's 2 cosmonauts currently on board the ISS started cleaning off the station's illuminators. That's space language for windows. The astronauts reportedly discovered the plankton after examining the residue on the illuminators. State-run TV network RT confirmed the news, also referring to the find as a part of a study. Since the plankton isn't native to the ISS resupply launch sites in Kazakhstan, the prevailing theory appears to be that this plankton was blown into orbit from the surface of the ocean by rising air currents. If that sounds pretty far-fetched to you, then don't worry. NASA's a little skeptical of the news too. A NASA spokesman told Space.com the agency hadn't been informed of the discovery and noted the Russian astronauts weren't looking for plankton while cleaning the windows. What they're actually looking for is residues that can build up on the visually sensitive elements like windows. That's what they were taking samples for.
When you connect the dots, the light goes on.
And Houston on one with the water in the helmet report.
Go ahead.
Yeah, Terry was saying that he's got some water in his helmet. He just noticed it a minute ago. It's about 3 inches in diameter. It's kind of pulling on the front side of the helmet above his eye level, and he does feel a little bit of squishiness in the back of the hat. Not bad. I'm watching. I don't see anything dramatic, and if you agree, I'll just go ahead and take him out.
Wow, Terry, you look better than I remember you.
When you connect the dots, the light goes on.
Well, a potentially deadly situation forces one astronaut to cut his spacewalk by more than half after an equipment malfunction in outer space caused him to nearly drown inside of his own suit. It's an incredible story. Trace has more for it. Sam is in Los Angeles.
Yeah, we all know, Martha, these spacewalks have become kind of routine when you're out there, but the bottom line is every astronaut knows when they step out of that capsule or space station that even the smallest nick in their spacesuit can mean instant death. This was an Italian astronaut. His name is Luca Parmitano, and he was on a 6.5-hour spacewalk. He was about an hour and a half in when he felt water on the back of his hands and then on the back of his head, and the water was increasing. Listen to him now. Try to figure out what the problem is. Play this.
Yeah, I'm thinking that it might not be the water bag. There's no other place for it to come. Unless it's sweat or urine. I guess it must be sweat then. Yeah. How much can I sweat though? My head is really wet, and I have a feeling that it's increasing.
Yeah, I mean, how much can you sweat? He knew it was definitely increasing over his eyes and then his nose and then his mouth. And in zero gravity, the water just kind of pools like a big blob. And it's not like he can just step back inside the capsule or the station and then pop his helmet off. It took 24 minutes to get him back inside. And then you see there another 11 minutes to get his helmet off. NASA says he could easily have drowned, but he was very calm the entire time. Listen.
You can imagine, you know, you're in a fishbowl. So go stick your head in a fishbowl and try to walk around, and that's not anything that you take lightly, and certainly EVA is dangerous already. And he did a great job of just keeping calm and cool and getting his way back to the airlock.
Did he ever? About a gallon of water actually seeped inside his helmet. Still unclear if it came from his cooling system or from his drinking system, but as you might imagine, Martha, NASA wants to figure that out before they send somebody outside again to have the same thing happen all over again.
When you connect the dots, the light goes on.
Amazing. I'm here in Houston, Texas at NASA's Neutral Buoyancy Lab, the NBL. I'm here with Chris Hull. He's a Dive Operations Specialist 3, which means you're an instructor here. Yep. Now, Chris, tell me what this facility is, because it looks like a giant swimming pool, but not like any swimming pool I've ever seen.
Well, it is a giant swimming pool, but what it is it allows us to train astronauts to go outside and do EVA, which is essentially spacewalks. So what they can do before they ever go into space is get a chance to put on the suit and go through the tasks that they're going to be asked to do if they are asked to do one. If they're asked to go outside of the spacecraft, they're prepared to do that. They know how to work with the suit. They know the tasks that they're going to be doing. And they've done it 10, 20 different times in the pool before they ever get sent and asked to do it in space.
So the astronaut corps, when, you know, whatever the class is, they get suits fitted, and the EVA suits and special EVA suits for underwater. And here's where they simulate fixing a space shuttle, fixing the ISS, or working with other modules.
It is. It's the same suit. It's a suit that was on station that has been decommissioned. Yes, some things have been made different for the water, like we use umbilicals. Up in space, they don't have that. In space, they have a computer on their chest. We have a mock-up that helps us weigh them out, either by putting foam on it or by weight on it, depending on the subject. but all the suits are customly made to that astronaut as far as length, as far as glove. You want to make sure that it's a good fit. You're not getting hot spots, it's not rubbing on you. Astronauts could be in these suits in space 8 to 10 hours. In our pool, they're in for 6 hours at a time.
How does this facility, how does being underwater, what do you do to make it simulate gravity, zero gravity as much as possible?
Well, we have the three-dimensional axis. They can go up, they can go down, they can go left, they can go right, they can turn upside down. So it's the closest thing that we can simulate right now.
When the NBL was originally built, you guys made it for the space shuttle, you guys have had mock-ups of space stations, and right now there's mock-ups of ISS modules. So can you talk about a little about what those mock-ups are and how they function?
Now the mock-ups that you see in the pool are one-to-one config. Different material. Obviously, it's got to hold up to the water. We don't need the electrical or any of that.
None of the interior.
None of the interior. It's all the exterior. As far as every rail, as far as every bolt, as far as where every rail should be in place. If they have to go turn a bolt 98 times, they have to do that in the pool because they're going to have to do it in space.
So Japanese module simulated?
Yes. In that far corner, we have the Japanese section. It's got the Japanese exposed pallet. The Columbus is the European portion. The lab is kind of the U.S. portion. So it is an international space station, and the Russians have their own section out towards the back.
Do the Russians have their own NBL equivalent?
They do. It's a much smaller pool. It's nowhere near this size, but they do their own training with their own suit. Now, the Russians don't use the same suit that we do. They use the Orlan, so they train specifically for that over in Star City.
When you connect the dots, the light goes on.
Next, there will be some shots about the boom deploy. We are very much into TSS deploy activities. The first thing, of course, is to deploy the boom. The purpose of the boom was to basically take the satellite away from the orbiter structure. This is an accelerated view, which normally would take about 12 minutes. The boom is an incredible piece of engineering. You can see it in these shots. You can see the actual tether in the middle and all the electrical wires.
Basically here, at this point in time, there's 4 of us that were awake, the 4 veterans, the 3 rookies were sleeping. And of course, the very first concern we have is to make sure that none of this ball of tether starts coming back towards the orbiter. We were concerned pre-flight, and we did a pretty good share of training pre-flight that if we had a ball of tether coming back at us, we'd do the proper evasive maneuvering to make sure we didn't have a big problem.
You guys getting the image?
Franklin, we see a long line, a couple of star-like things, and a lot of things. We see a long line, a couple of star-like things, and a lot of things swimming in the foreground. And a lot of things swimming in the foreground. Can you describe what you're seeing?
Well, the long line is a tether, and there's a little bit of debris that kind of flies with us, and it's illuminated by the sun at such low angle. So there's a lot of stray light, and it's getting washed out quickly. But Claude is trying to do a quick, good job here adjusting the cameras.
Columbia, Houston, that's a much better view, a lot more contrast visible. And how wide does that tether appear to be? It seems to resemble a much wider strand than we'd expect. Can you describe which way the satellite is visible on that strand?
Satellite now 100 nautical miles.
Charlie, completely unzoomed, and you see the full extent of the tether. I tried to adjust the focus, but I can't get better than that.
Okay, Claude. Thank you.
I'm going to zoom in now.
When you connect the dots, the light goes on. When you connect the dots, the light goes on.
The unique experience is a really good way to describe it. There's one aspect, the part of being outside that is really similar to being in the NBL, the training facility, the neutral buoyancy lab, the big swimming pool we have at Johnson Space Center down in Houston. Everything looks the same in that swimming pool, but outside, there's a big Earth going by. There's sunsets and sunrises to kind of wake you up or brighten, kind of blind your eyesight, and so just the view is what's completely different. That's what takes your breath away when you're trying to get back to the business of doing your work, and amazingly enough, the Earth is just rotating by underneath you.
And, we talk about spacewalks, but it's a bit of a misnomer. It's more like space floating. You're really not out there walking. And I guess the best analogy I can tell everybody is if you could imagine yourself scuba diving in a suit of armor, that's about what spacewalking is like.
And the wide field planetary camera 2 is clear of the structure of the telescope, and now Foista will be maneuvered by Megan.
Well, the indicators look a good bit different than what they do in the pool, but what I see is two black squares with a white dot in the middle. So I can describe to them what I see here, Chris. It's a lot different than the pool. So
when you connect the dots, the light goes on.
Listen, all these noises, and tell me this is at 400 kilometers high in the vacuum of space where there is no molecules to make the transmission of sound. And remember, they say it's 400 kilometers high, 2,500 Celsius, and it's again now another rain of air bubbles. Not one, not two, it's a gazillion. I want to see how do you debunk this. It's debris from space. You got to be blind if you believe that. Look at that. It's too many air bubbles. More bubbles. When I saw Eric Dubay video about bubbles, you think maybe it was just the one or two, but if you go in every spacewalk, from NASA, Chinese, Russia, whatever, if you go, all of them have space air bubbles. That's a good fabric for protection of the vacuum of space. Here is a helmet and glove check, and will be fun because the helmet and glove check is to check if they have water. That's fun. Water. They are in the vacuum of space. Should be no water there.
When you connect the dots, the light goes on, and suddenly the picture forms. The multitude is always wrong. And invariably, when you look through what we call history, it turns out that way. It is the people who have challenged that have moved us forward in terms of our understanding of who we are and the nature of the world we live in. Few centuries ago, the majority believed. Why? Because those people perceived to be all-knowing, the scientists and religious people of the day, said the earth was flat, and if you went too far, you'd fall off the edge. And people were jailed and vilified for saying, actually, it's a sphere. And then when the evidence becomes overwhelming that the earth is actually a sphere, then that becomes the new norm, and now anyone who says that it's flat is now ridiculed for believing that.
The distribution of the continents on the earth according to their ratio sizes and distances between, so time, hours, sun travel. The center here, this is where the sun, when it goes around the equator, which is this circle, the sun, when it goes around the equator, the center of that circle is here. Now, this center never stays fixed. It's continuously moving, always has done, always will do. It moves from this central point here down to this point as the sun narrows to go around the Tropic of Cancer. It then swings back towards the center and then over this way to here when it goes around the Tropic of Capricorn. The sun is not at a fixed distance from the surface of the earth at any point. Its circuit is continuously oscillating. We'll make it an oscillation with my hand. It is continuously doing this. I'm exaggerating, but it is continuously doing this. So trying to get readings of the sun in terms of distance with a protractor, we're always going to have questions because the center of this oscillation also moves. So this oscillation you can detect. First of all, you can see that this is the line for the Tropic of Cancer because here's the Sahara, here's the Arizona, and here's the Gobi and the Asian deserts. This is the Tropic of Cancer. This is the equator, therefore the equatorial regions where jungles are on the equator, including the north of Australia, which was described by Cook as a tropical zone. They actually thought it was utopia. The same with these islands, Indonesian islands, Thailand, India, even this region of China. And here, you know, the jungle in Africa. So you have the Amazonian jungle, the African jungle, and the Asian jungles. Now, as the sun makes its way round, being propelled by a magnetic force which vortices out as a toroidal form in a corkscrew type of shape. It basically opens and spreads. So let me move this towards the camera. It opens and spreads like this. Propelling the sun, helping the sun, it's a feedback loop. Now, this force that pushes the sun also pushes moisture. So as the sun arrives to this area, it drops moisture. Now we're going to concentrate on when the sun is in the area where it can create deserts. So it makes circles and it gets to a point, it's making a circle there, it stops spreading outwards, and then it starts to spread back inwards, back to the equator. So when it slows down from speeding out, so when the spread outwards slows and the concentrism starts, at that point there's heavy heat, which causes the deserts here, here, and here. Now, as the sun arrives, it brings with it moisture. So you also have areas of moisture, humidity. You have the areas on the other side of any landmass are more arid than the areas to the east, because with the sun also comes more moisture. So the same here, the east has more greenery, and here the east has more moisture. That moisture is exhausted by the plants, and then you have more arid atmosphere. The same in the Tropic of Cancer. You have more moisture here, more moisture here, more moisture here, because as the sun arrives, it pulls with it moisture. This is just my thinking, okay? Now, the Tropic of Cancer goes around this area. You'll notice it comes very close to Alaska. This would be the sun circling over the flat Earth in the northern summer. So if this was correct, then Alaska would be kind of warm in the northern summer. Well, lo and behold, it is warm in the northern summer, given its supposed latitude. The latitude that we have, that we inherited from the globe, is a mathematical matrix for making a globe. That's all it is. We can completely discard it. Now, is there anything that could kind of confirm this? Well, strangely, yes. There are these readings to confirm the sun's proximity. Not only that, but there's also this. You'll notice here, that line, that just happens to coincide with the eclipse of 2017. Now, I've not drawn this based on the eclipse. I drew this, and then Hillbilly came and explained about the eclipse, and we looked at it, and it's like, yo, this is mighty close to where I've drawn this line. Now, I'll show you what the eclipse is going to do. This is the region where it's going to fall. Now, it should fall. This is where I have the Tropic of Cancer at this point, for this time of year, this being the June solstice. Now, like I said, the centre is continuously shifting, and the sun is continuously making a narrower circle with a limit and an outer, wider circle with a limit. And with the centre shifting with a regular motion, but continuously shifting this way, down the prime meridian towards the UK and Paris and Spain and Northern Africa. So down this way, back to the centre, down across this way, back to the centre, down this way, back, down this way. Now, when it's here, this is the Tropic of Cancer. This is the northern summer. The eclipse, the total solar eclipse of 2017, August 21st, is in the northern summer. It will fall in this area that just happens to coincide with where I have the Tropic of Cancer. Now, the sun should be just off because it's gone beyond the height of the summer. So the sun will be going back towards the equator in its continuous spin. And the shadow will fall respective to the distance between the sun and the moon. So the shadow should be just slightly north of the sun's actual circuit, because the sun is much closer to the surface of the earth than we've been led to believe. The reason we've been thinking 3,000 miles is based on the protractor. The protractor gives false readings. I explained this in a previous video. I'll go over it now too. So, because the protractor is a mathematical tool, the protractor does this. Let me move these. The protractor does this. This is not a magic trick. This is a protractor. This is solar noon. This is looking from the south to the sun. Solar noon, 1, 2. You see the distance between is pretty similar, but it starts to space out more and more per hour to the point where you have solar noon, 1, 2, 3, 4. Between 5 and 6, this area is more than twice that. In fact, it's like 3 times this. And here, we'll keep it here as a limit, okay? We'll say this is solar noon at some other point on the Earth, okay? 7 hours away. So this is solar noon in, say, Chile. 7 hours later, it should be solar noon in, say, Perth. But the sun, between that solar noon and the following hour, so if we place this now here, would move only this much, same distance as here. So from here to here. Not only that, but the sun will have arrived in the reverse order of this. So at sunrise, between sunrise and the next hour, there's a big piece of distance covered. So this is telling us the protractor gives us false readings. And if we've worked out angles based on the protractor and the location of the sun directly, then we have arrived at an error for the height of the sun from the surface of the Earth. So Eratosthenes, sorry mate, but you messed up. This is the same for the north. So solar noon, if we ignore these numbers, solar noon, 1, 2, this is where the sun would be as it scrolls across the sky. And this messes up the globe too. This is not just a false reading on a flat Earth. This is a false reading on the globe too. The protractor gives us false readings when it's measuring something when it does not know the distance to that object, especially if that object is an optical illusion, which the sun is. It's an optical illusion like this. What you're seeing here, that sun, you see reflected in that mirror, you'll notice as the person filming this shifts their angle to the sun, you'll see parallax. Parallax being where the foreground moves in the opposite direction to the background. So the foreground is moving to the right and the sun is moving to the left. Well, this, ladies and gentlemen, that beautiful blue sky, that is a skylight lamp. That is not the sun, it's an optical illusion. The result of the synthetic compression of the very same gases we find in Earth's atmosphere. Again, that is not the sun. Now, a different representation of what the Earth might look like, according to me, something like this. We have the denser vegetation, the jungles. So this area is jungle, this area is jungle, this area is jungle. As the sun arrives, it deposits moisture, and then you have the arid areas. Deposits moisture, then has the arid areas, apart from when elevation comes into play. So if there was something of a higher elevation here, which would cause a drop to the other side, say the Rocky Mountains, then you'd have moisture here like the Californian redwood forests. And that's what you have. Here you have this area. In this area here, you don't have desert. You'd expect desert, like you have desert here. But what you have here is high elevation, which means more moisture. As the sun goes round, arrives here, deposits moisture, so you have more vegetation, and then you have desert. My theory is that the same energy that pulls up and reaches up and propels the sun, the dynamics of which would look like this, is the same energy, the same magnetic force that drives land masses up. And because the sun makes it a narrower circuit around the north, this would explain why there is more land masses in the north. The spacing of these three could be due to the combination of electromagnetic anomaly and thermal anomaly. An interesting point is this. As the sun goes from orbiting around the central point at the equator to orbiting up around this point for the Tropic of Cancer, the central point has shifted. It has shifted from here down the prime meridian. So what could be causing the center to have shifted? Could it be a magnetic anomaly located here? Not only a magnetic anomaly located here, but a magnetic anomaly that is located here and reaches across. So the sun would be drawn towards it, fall back towards the first point, drop down to this point, be bounced back, drop this way, back to the north, back and forth continuously. If the center of spin is being drawn this way and drawn this way, because there's a magnetic anomaly here, you'd expect this to be balanced out by a thermal anomaly over here somewhere. See what I did? I kind of went for like the center of the magnetic anomaly and went straight across from the center of the anomaly, which would be here, across a medium point between these 2 points over this way. That there is where I would expect to be some kind of thermal anomaly. And lo and behold, here it is. There you go. Being pointed at by Thailand. If Thailand's a finger pointing towards it, that's where it is. And as a dynamic energy, it shifts, just like the magnetic anomaly. And magnetic north, magnetic south. That's my theory, and I hope you enjoyed it. Now, I will be making... where is it? Thanks to some very generous people who are going to give their time and render this as... they're going to vector this. This is what I will make available. I did originally have the continents separated, and then I thought, actually no, I'm not going to do that. What I'm going to do, though, is I'm going to have all of the longitudes completely removed. Not only the longitudes, but the tropics too, so that you still have to get your compass out and your ruler. Now, you'll notice here the positioning of South America. Now, I want you to think of a globe, or even the Gleasons, and how South America is located. The way it's located is you have this area is an hour to the east, and this area is 2 hours to the east. Now, in the real world, this area is an hour to the west, and this area is 2 hours to the west. If we say this is a meridian, if we say let's have this as a meridian, let's just determine that, okay? This is an hour to the west of that meridian, and this is 2 hours to the west. from that meridian in the real world. How do we know this? Because when it's 6 o'clock in New York, it's 4 p.m. When it's 6 p.m. in New York, it's 4 p.m. in Buenos Aires. When it's 5 p.m. in Michigan, it's 4 p.m. in Colombia. The opposite of what the globe says. And this is why I think YouTube is compartmentalized so that cooperation between South America, North America and the rest of the world is so detached. It's not just language. Belize speaks English. We don't have anything from Belize. So, and not to mention the majority of the countries in South America speak Spanish, and Spain is over here in Europe, but we don't have this cross-referencing of points. So I think the reason that we're being kept separate from further readings is that confirmation is very easy. It was only by accident that this was noticed by me with Isa Mahal and Lady Ganja, and then subsequently by Robert Bassano and Political Hillbilly, who noticed that while Robert Bassano was in Medellin, in Colombia, 1 hour west of Political Hillbilly, the Globe and the Gleasons says that they are 1 hour east in Medellin from their true location. So, I hope you enjoyed that. I hope that makes sense. Lastly, I will explain the crazy squiggle that I was showing for the vortex. This was written by Tesla. And the squiggle was drawn by Tesla. That crackpot. That retard. So, let's read what he says. I have worked out a dynamic theory of gravity in all details and hope to give this to the world very soon. Unfortunately, he was 82 at the time. It explains the causes of this force and the motions of heavenly bodies under its influence so satisfactorily that it will put an end to idle speculations and false conceptions as that of curved space. According to the relativists, space has a tendency to curvature owing to an inherent property or presence of celestial bodies. Granting a semblance of reality to this fantastic idea, it is still very self-contradictory. Every action is accompanied by an equivalent reaction, and the effects of the latter are directly opposite to those of the former. Supposing that the bodies act upon the surrounding space, causing curvature of the same, it appears to my simple mind that the curved spaces must react on the bodies and, producing the opposite effects, straighten out the curves. Since action and reaction are coexistent, it follows that the supposed curvature of space is entirely impossible. However, even if it existed, it would not explain the motions of the bodies as observed. Only the existence of a field of force can account for them, and its assumption dispenses with space curvature.
Well, basically, it's just impossible. It cannot work in the vacuum of space. It's just impossible. Physically, it's impossible. Yeah.
So, what about all the scientists? Are they all lying, or?
The thing is that we have understood the word scientist wrong. Look, I'm a scientist. I'm a mechanical engineer, and I have a master's degree in technical physics. And I work as a research and development scientist. But when you say a scientist, you think that these guys are out there and they're just exploring the universe and trying to find the secrets of the universe. No, it's not like that. They pay us to do certain things, certain tasks. And if they don't pay me, I'm not going to go search those stuff. Even if there are some people like me who do think about it, the thing is that since childhood they tell us that the rockets do work and the NASA is sending stuff up into the space, and so you're just programmed since childhood. You're not going to be questioning that program. And even if you do question that program, people will laugh at you. People will judge you. They think you're stupid. So you end up losing your jobs and friends and stuff. So the scientists, they don't do that to themselves. It's a stupid thing to do. Even if it's the truth, but you just don't do it. The reason that you do think that rockets work in the vacuum of space is because of the third law of motion. The third law of motion states, it says that for every action there is an equal and opposite reaction. So it's really easy to test that. Let's put this into action. An action is, for example, I'm going to start punching now. So I'm punching and I don't feel any reactions. Do you see reaction? I don't feel any reaction. But then I start punching the wall, I feel the reaction. I mean, you can try it. You feel the reaction. If it starts hurting, and if I punch harder, it's going to bleed, and if I punch even harder, it's going to break my bones. So it seems like the third law of motion, where in order for you to get the reaction, the equal and opposite reaction, you have to apply your action on something. If it's nothing, then you don't get the reaction. For example, if I'm now pushing, I'm now pushing myself, okay, I'm pushing my hand, and no reaction, I don't feel any pushback. But then I push the wall, and I feel the pushback. So you cannot just push nothingness and expect something to happen. There has to be something.
But what about if I, for example, in a skateboard and I have a bowling ball, let's say, and I throw it, I go backwards. So
look, when you are standing on a skateboard and then you are pushing a 15-pound bowling ball, that 15-pound bowling ball has a static inertia. It means it wants to stay static. It doesn't want to move. So when you're pushing that, you're pushing yourself back. If you think that the third law of motion works in these kind of cases, then you can just throw a pen. Just see if you go backwards when you're throwing a pen. Throw a balloon, throw a light object. And yeah, cool. So you have a balloon, and you can push the balloon and see if you go back. Or a ping pong ball. It doesn't happen. The same thing when you're pushing a car. You know, have you ever tried it when a car is broken and you're pushing it? At the beginning it doesn't move. It's heavy. And then after some time it just moves slower. It got out of that static inertia. It's now moving, so it's easier to push it. It's not that difficult. So in order to get this reaction, you have to push against something. Otherwise, it's not happening. This guy, the reason it goes up is this high velocity and hot gases that exit the exhaust of the rocket engine will push against the ground first, and then it takes off. When it goes up, the air down here becomes thinner. But even if it's thinner, the speed of these gases will turn that thin air into a barrier. You know when you're, for example, driving in the highway and you stick your hand out of the window and you feel this pressure, and the faster you go, the more pressure you feel? That's the same thing. Even if your hand is small, when the speed is high, the pressure increases. It becomes a barrier. The same thing in here. It pushes these hot gases and high velocity gases down. Even if it's thin, it still creates a barrier out of them. So as long as there is air or thin air, the rockets do work, but when it goes out in the vacuum of space where there is nothing, then it's nothing. You can push it, and nothing will happen. This is easy to test, actually. Look, you can get a simple drone and just put it on the ground, accelerate it, so it lifts up from the ground and hovers at 20 centimeters. Do not touch the accelerator anymore. Just put a cardboard sheet under the drone and just lift it up. When you lift it up, the drone starts coming up also, and it maintains the same 20 centimeter distance between the bottom of the drone and the sheet. And the moment you take the sheet out, you take it away, the drone just drops down, hits the ground, and the hitting the ground happens due to inertia. Hits the ground, comes up, and maintains the 20 centimeter distance. So based on these observations, based on what I just showed you, pushing, punching, and the drone, which I can show you actually, we can go outside and I can demonstrate this. It's impossible for the rockets to work in the vacuum of space. It just doesn't happen. The paired law of motion happens when you apply your action on something, and that something can react to you. When there is nothing, there is no reaction. Simple as that. Yeah. And the thing is, many people say that the rockets don't work in the space because there is no air. No, you're just misunderstanding it. They're carrying their own liquid fuel and they're carrying their own liquid oxygen, so they don't need air. That's not the problem. The problem is this pushing act that you have to push on something.
So you will say that they don't move. They cannot move up in the outer space.
When you're in a vacuum, no. This doesn't produce any thrust.
Even if it's like it's producing its own fuel, it wouldn't move.
It wouldn't move at all. Because as I said, you have to push against something in order to feel that reaction. And back here is a vacuum now. I mean, everywhere is a vacuum in this space. So there is nothing to push against, and done. It's just not happening. So yeah, we can actually go outside and try the drone thingy. So I'm not a good pilot, so I have to try to balance it first, but let's try our best. Okay, there we go. So as you can see, I'm not pushing the gas anymore, and we go up. You see, I'm not touching the gas. And then it comes down. You go up, as much as you want, and there you go. And the 20 centimeters is maintained, and then we go up again. You see, it means something to push against, otherwise it drops. Yep, simple as that. Based on this, you can see rockets just cannot work in the vacuum of space. It's done. There is nothing you can say about this. It's over.
If you did like this video, give it a thumbs up, and if you didn't like it, Give it a thumbs down. If you haven't subscribed, hit the